Hi, my name is Jack Fernandez. I'm the team lead for the Honeywell Composite Metallic Stator Vane. In front of me is one of our completed composite metallic stator vanes. For Honeywell, they're completing the HCF 7000 has a fan outlet guide vane. The goal of our project was to introduce new manufacturing strategies and record that, document it, go through all the analysis and feasibility of what this full manufacturing cycle will look like, and that will be laid out in front of you.
My name is Ian Keith, and I'm a mechanical engineering major. Our approach to the problem was first defining the different requirements and constraints that our part would be under, whether it was aerodynamic, structural, thermal, or manufacturing requirements for the Stator vane. We then reviewed industry standard and open source documents to make sure our geometry was on par with that industry. We then went through and did material selection and manufacturing selection by evaluating candidate materials and landed on a pre-preg by creating a mold and then laying up that pre-preg within the mold as well as our leading edge. A series of different CAD models were created to and iterated so that our design was proficient, and then we went through and performed analyses such as CFD, FEA, and modal to make sure our part hit every requirement and was verified.
My name is Mikael Reese. I'm the industrial engineering major. Going into our point design, we were trying to find a different way to manufacture the composite body of the Stator vane. Honeywell already uses injection molding, but we decided to compare compression mold, resin injection, and pre-preg system. We decided to go with the pre-preg system. However, after doing our testing and manufacturing, we decided that the current method of making it is better. We were also suggested to do 3D printing for the metallic leading edge and then machine metal mold for the molding of our composites.
My name is Jose Rodriguez Vargas, and I am a mechanical engineering major, heading into our first system requirement of the composite body featuring a metallic leading edge. A 3D scan test was done to verify our results to be compared to our CAD model. For our second system requirement, max temperature was derived. A material was selected based on that temperature, and data sheets will be provided in the final documentation to verify that. For our third system requirement, we ran modal analysis at a given 95 to 105% speed range. We wanted to avoid those frequencies for any mode crossings. For our fourth requirement of an aerodynamic load, we conducted a 3-point bend test. The margin that we were given by Honeywell, which was required, was 100 pounds with a factor of safety of 1.2. We exceeded that factor of safety with a result of 1.4. For our fifth system requirement, we were tasked to do an foreign object debris impact test. With no given margin, we conducted a practical impact test based on simulations that were done.
Hello, my name is Stator Figueroa. I'm a mechanical engineering major. For our results section, we computed computational fluid dynamics, CFD. With this, we were able to see recirculation zones, aerodynamic performance, and overall the aerodynamic load. With this, we iterated our design to improve performance accordingly. Next, we conducted FEA, finite element analysis. With this, we saw that the leading edge experienced the highest amount of stress, and the composite body itself experienced lower stress. We also got important information such as deformation and the maximum amount of stress. With this, we were able to conclude that the structural requirement was met. Next, we did modal analysis. Modal analysis allowed us to calculate the natural frequencies. The natural frequencies were different from that of the operating frequencies, meaning that resonance is unlikely to occur. Finally, with all these results, we were able to determine that the part we designed was overall structurally and aerodynamically met all standards. Finally, we also did a manufacturability performance to see and cost to see whether this part is feasible in real-world applications.
Hi everyone, I'm Vignesh Maharajakanan and I'm a student majoring in aerospace engineering. Using ANSYS, I worked on flow analysis to understand how fluid moves through a system and how factors like velocity and pressure changes. The purpose of flow analysis is to help engineers design safer, faster, and more efficient products. CFD, which stands for Computational Fluid Dynamics, allows us to simulate fluid behavior on a computer before building the actual model. This saves us time, reduces cost, and improves accuracy in engineering design. Thank you.
The bend test for this project, we used a hydraulic press to load the stator vane to the aerodynamic load of 120 pounds. The setup was 11.25 kilograms, meaning a final weight achieved was 65 kilograms. We went to 75 to get a factor of safety of
1.4, which exceeded the requirement of 1.2.
Our impact testing was done to address our system requirement of assessing our stator vane's impact characteristics with a foreign object debris test. To do this, we conducted preliminary analysis with LS-DYNA, created the necessary equipment for a bird ingestion test, and conducted the impact test itself. This movie is a result of the LS-DYNA simulation using a bird model. In this graph, we verify our simulation was set up properly and that energy was conserved throughout the simulation. In this graph, we show the max deformation of our leading edge over the simulation period. Prior to our impact test, we calibrated our cannon by measuring the speed of the projectile frame by frame, as seen here. Finally, we recorded a video of our impact test.
Our deliverables will be a detailed manufacturing process for Honeywell for the hybrid composite metallic stator, as well as the creation of full hybrid metallic stator prototypes. We will do a cost analysis and business considerations mixed into that manufacturing process, as well as a full analysis of the core stator structure with all of those CFD, FEA, modal analysis in. And we will also have a bonding and material selection included for Honeywell for our material, or for our stator.
My name is Jacob Akwili. I'm the procurement lead for Team 26029. I'm an aerospace engineer. There were many surprises along the way of our senior design journey. And a lot of them came from working in this professional environment at a company like Honeywell Aerospace. We had to learn the importance of communication between our internal team at U of A and our sponsor, and working through any of the problems that we had. So some of the lessons that we learned were tied into those problems, like outsourcing our materials from third parties and purchasing our leading edges from places like Xometry. They gave us insight on the process of purchasing these materials, as well as troubleshooting any issues in terms of delivery and any defects. There were also things like retrofitting our PVC air cannon, which we had to troubleshoot and figure out any of the issues and solve it as fast as possible. Additionally, there were also things like CFD, which we had to learn computational skills and all of our other analyses.
Alrighty, so going through the safety environment for our project, because we were working with composites, we're doing impact tests, we're dealing with high temperature cures, there's a lot of safety concerns for our project. Throughout it, we use proper PPE such as respirators, eyeglasses. Then when doing the impact test, we also included things like doing hydrostatic tests on our pressure equipment, using face shields, using full welding bodysuits, and high temperature gloves. All of this helped us work carefully with this material and ensure a safe environment.